Now ladies and gentlemen, let's look at this point. We already found the point of inflection to lie over there. Do you see that? Okay, and then we said, okay, if I go down, this point is minus 2 over 3. Now I need you to give me any x that is convenient, that is on this side, in other words more than negative 2 over 3, but that's easy for us to use. 0 is an easy one, right? And 0 is bigger. So I'm going to use x equals 0, and give me something that's on this side that's easy to use.
Negative 1.
Negative 1, right. Now I'm going to put those 2 points into the second derivative of this function. So let's go and look at what the second derivative looks like. Do you agree with me that the second derivative for the function that we have just graphed is equal to 6x plus 4? So f double prime of x is equal to 6x plus 4. Now you know the point of inflection, right? This is point of inflection, not power over, never mind. This will be negative 2 over 3 and 2 comma 5, 9. We take an x bigger than this and x greater than that, x equals, what did we say? 0. And an x smaller than that, on the left hand side, we take x equals negative 1. Let's put each of that into this function above. So I'm going to find f double prime of negative 1. Because I'm a nice guy, I'm going to work it out for you there. I'm going to say 6 times minus 1 plus 4. What is that equal to? Negative 6 plus 4, which is equal to negative 2. Right? Then, let's take the other one. F double prime of 0. That's going to be 6 multiplied by 0 plus 4, which is going to give you what? 4. Now people, I've chosen 2 points. Do you see this? Or 2 x values. One x that's after the point of inflection and one x that's before the point of inflection. Here I can say that f double prime of x at that interval, or say of negative 1, is less than 0, and here f double prime of x, or of 4, is greater than 0. Here I'm saying another word for greater than 0 is what? Positive, and for less than 0, negative. That means before this point, because it's negative, it must be concave down, and after that point, because the second derivative was positive, it has to be concave up. And do you see how we use the properties now of concavity to also draw the graph? Okay, so given that we've now interpreted when the second derivative at a specific x value is 0, it means that on that interval before the concavity changes, if it is negative, it will be concave down. If the second derivative is positive on a specific interval, in other words, specific different x values that you put in on the same interval, and it leads to a positive, then you know that it has to be concave up. So this gives us properties of the graph in terms of its shape. Okay? So now your work is to do the remaining 3 curves, okay, and find the point of inflection. It's mechanical and it's simple enough to do.